There you go.
Good.
Okay. All right, when you're ready, you can go ahead and unmute your mic. Go ahead and change your slides to presenter view.
So the mic is turned on?
Yeah. Oh, no, your mic is going to come from your laptop. So
Oh.
you just have to turn your mic on for your laptop.
Okay.
Here you go. Hey, mic's already on. Let me go ahead and test audio.
I can present a bit.
Turn your volume down just a little bit on your laptop.
Volume down.
All right. Go ahead and introduce yourself real quick.
Okay, sure.
Up on this.
Sure. Hi, everyone. My name is Amit Gupta. I'm filling in for my colleague David Balling, and we're at the R training. So I'm going to be, are you hearing me okay? Jason? Okay. So welcome, everyone. So I'm going to be covering some introduction, basic things on R and the RStudio IDE. And my colleague Riju is going to be covering some aspects of parallel R, and it's going to cover how to use R on our systems here at TAC. And so let's start off quick. So this is the rough agenda for today. We're going to have about 45 minutes on basic R introduction. And we're going to have some time to launch RStudio, the IDE for R development on one of our on our Viz portal, one of our machines, and you will have some time to practice and do some exercises on RStudio as well. So, and after that, we'll break for about 15 minutes, and Riju will be covering R on our systems. Following which, he will cover how to run our jobs in parallel, at least some of the ways. And we'll also have some time for Q&A. So let's begin with what R is. It's basically a programming language designed for statistical and data analysis. And it has a whole host of mature functions for statistics, a lot of functions for plotting. As you will see later, our plots are extremely professional looking, and you might choose to use them in your work. They have a lot of easy functions for data handling, for storage, and you can do all of these things programmatically. It's also open source, so it's free to anyone. You don't need any kind of license that you have to pay for, and it's constantly being improved. There's a very active community around it, and for almost any kind of data analysis, you will find some kind of sub-community within the larger R community, and you can find a sub-package that would that should work for any kind of needs that you have.
Lost the screen share.
I see. Okay.
I apologize, folks. Just one moment.
Yes. I see there. Does it mean it's sharing?
Okay.
I can see an interruption there.
Let me see.
Okay, and also, so if you want to visit the project page, it's rproject.org, and you'd find a lot of information there. There's also there's a very useful website. It's not included in the slide, but it's called R Bloggers, and you have R users actively posting different kind of tips and tricks that they learned, which you could gradually add into your repertoire. And so they're both very useful sites. As a programming language, it has full functional programming support. It's high-level language, so it's easy to use. You don't really need to. It's not that hard to program. It's fairly intuitive, and it is pretty high performing, but it's also as we can see, when you want to fine tune the performance, you can use a lot of parallel R packages, and it's also you can program it interactively, meaning you go one step at a time. So you run a statement, and then you can see the result. For instance, if you want to, when you've handled your data, you can plot it. So you run a plot function, then you would examine the plot, then you would, based on that, you would make some adjustment or some adjustment to the data, or tune some parameter, run another statement. So you could run it interactively one step at a time. Or you could process all your instructions in one script, this is what we're referring to as batch processing. And so you could do it either way. It has a lot of functions for processing data in various formats. And so you could process XML and CSV files fairly easily with just a function call. So those are pretty easy. So let's proceed to the basics of R. The basic abstractions are variables. Then you have more complicated data structures like data frames and matrices and vectors. And then you have the other thing to learn there would be controlling the flow of if you're writing a batch script. So if-else conditions and loops and so forth. These are just basic things that you would learn in any programming language, and so you would learn them in R as well. So the basic interface to R was traditionally this command line interface, like if you would go on your shell in your Unix machine or Linux machine, and if you had installed R, and if you just type in at the command line, you would see a prompt like this. You could always for help on any command, you could always type a question mark and type the command name. That's a way to access the help, the reference, or the internal documentation that comes packaged with R for any built-in R command. So we can start stepping through it. So how do you get them into R? How do I what? Yes, you could go to your terminal program. So if you're using a Windows or if you're using a Linux machine, you would just open a shell, and then you would get the login prompt, and you would type in R. If you're using a Windows machine, if you've installed R, you would have an icon on your desktop, and when you double click, it would open a similar window to give you an R interactive shell.
But I am confused. In order to get it, one thing that I installed in my machine, and I know that it's to install it in the machine here.
Yes. So
in order to get into the machine here,
yes,
and to do it in R, what do I need to do?
We'll be covering that.
We are already there.
Correct. We'll be covering that. So as we mentioned, there's as part of our agenda, we'll be covering R attack there, and so those are the specifics of how to run R on our machines here. What we're covering right now is just an introduction to R for those who are unfamiliar with R, and just to show you what the basic interface looks like. So you could run it locally on your machine just to test it out. And eventually, when you need larger scale stuff, you could run it on the tag machines.
Then can you change the ordinary data scenes so that we can practice what you're presenting?
Yeah, there is practice time included there too. So
No, but if we can get into the machine, we can go with you what you're presenting.
okay. Richard, can you help them log in once?
I have everyone's username set up on an allocation.
Okay.
And we have a reservation configured.
Right.
So once you register for the course, we set you up so you can access it, and we'll provide you instructions on
So
Uh,
that's
sh-
the same, can you give us that?
She would like to do it now. Is her point? Yeah.
Okay.
Yeah. Okay.
Okay.
So we'll have people walk around and help you guys log in. And but there is time scheduled separately for that. So you want to just play along as we go here. So that's fine too. The easiest way to do that is actually if you installed it locally, and you just fire up a local client and get it going. So just to carry on. The first basic use is the basic mathematical operation. So you could fire up an R process and get the prompt and use it as a calculator basically. And so you could use logarithms, exponentials, and so forth. And so the basic variable types are numeric, which are basically integers, floating point numbers, and so forth. And it is treated as a single a vector of size 1, which is why you're seeing it like that. The way you print a variable is just to type its name in. And sorry,
You don't have to declare a type.
you don't have to declare a type, which is so it's dynamically typed. It would assign the variable based on the type you gave it. So if you would give it a string, so forth, you would just assign it this way, and it would store it as a string. And it can also another variable type is a logical, which is basically a true or false, and you could store the result of any conditional expression. So is 1 + 1, is it equal to 3? It's true or false, and you could store that to a variable. So it's a Boolean or a logical true or false variable type, a string, and a numeric. So these are the basic variable types. Everything else you see later is going to build on, is going to just be a collection set of one of these. And so in legacy R, the assignment operator was the one you see on the left, which is the less than sign and the dash. And this is just it's the remains of the initial operators they had, and they kept it there for back portability. It used to be really confused. That used to be the only assignment operator in R, but in later releases they also introduced the equal to make it more intuitive. So if you're working with any legacy R scripts and you see the less than dash sign, you just have to think of it as an equals to sign. It's the same thing. And when you're writing your own scripts, just feel free to use equal to. It's more intuitive. You don't have to worry about what it means, and you don't have to interpret its meaning, so forth. So basically, there are two assignment operators in R. You can also concatenate many variables of one type into a collection or a vector. So you could create a single vector of. So we have those integers there, and you want to accumulate them into a vector, and the collection operator is the concatenate operator is basically C with parentheses. You could also accumulate collections from your standard input using scan. So it's basically what's happening there is you're running scan, and then you get this prompt where you can feed in a number till you're done. So here you can see we fed in 5 numbers, and it accumulates that into a collection and assigns it to variable A. So again, it's dynamically typed, so we didn't declare what A was earlier, so we just dynamically assigned it a collection. And there are different shortcuts for creating a series. With the colon, you can see. So over here, what we're doing is we're creating a vector with a series beginning at 1 and ending at 6, and they're separated by 1 by default. You can give a custom separator of 0.5 and so forth as an argument to such a shortcut. And as you can see with the sequence, there's a sequence operator, and the third argument you give it is basically the step size. So it goes from 1 to 6 in steps of 0.5, and it generates the same collection that gets assigned to variables A. So the other thing is variables can also take a value of not available, which means it's not the same as 0, it's not false, it's not the same as an empty string. It's just that if a variable is unassigned, it takes this value. And the operations that involve a variable that is not available is implementation defined, so which means you can't really predict what that operation is going to do. So if you have an addition with one of the operators not available, operands not available, then the result of that could be depending on your R implementation. So the R client that you happen to be using at the time might handle it a different way. In the example where we tested this out, these are the results of these operations that would usually just lead to not available again. Same with the Boolean. And when you have a collection that has not available, it doesn't, like we're looking at this max function right here that's trying to find the max of 1, 2, 3 and a fourth variable that we don't know the value, and so that leads to an undefined result. There is a shortcut in the max function for removing all the variables whose value is not available. So what you see there is na.rn, which is remove all the not availables, equals set equals to true. So it just takes the collection, removes all the unknown values, so shrinks it down, and then runs the function on it. And so you would find often in your data sets when you're done scanning it, because of certain formatting issues and so forth, you might have a data set that is sprinkled with a lot of these values that are not available, and you have these shortcuts that can remove them from that. So it's effectively a data cleaning functionality, and you would find later when you deal with large data sets which might have these interspersed value errors, or if it's data from a sensor, maybe it was not able to read the sensor for that particular time interval, some kind of example like that, where you might have some data that is invalid and you want to clean it out of your data set before you run your processing functions on it. So yeah, so always be aware of the not available of the NA value. And so with that, we'll just start with some basic data structures supported in R. One is the vector. We've already seen it, which is basically it's a collection of variables of the same type, and you can usually access them through an index. So we've already seen a collection of 3 integers assigned to a variable, and you can index into it. So A of square bracket 1 means basically give me the first element, second element, And you could also run mathematical operations on them, like multiplying the whole thing by 2. So you get the whole collection with each element multiplied by 2. So the built-in mathematical operations get applied to each element of the collection. You also have matrices, which are basically a rectangular two-dimensional two-dimensional collection of the same variable type. And you could think of it as a number of vectors, row vectors stuck together. And so the two data structures that we've seen are to bundle collect different variables of the same type. Quite often, you might also want to do so for collecting different variables of different type and assigning them to something. Maybe they are naming different attributes of some particular object that you're trying to represent here. So you could do that with a list. And here, like you see, you have a string, you have an integer, and you have a Boolean, a logical type. And this is basically, you're trying to capture a record of a person with a name, age, and marital status. And you could index. So what we saw earlier was we could index into the data structure by number, but here you could index it by field. You could reference. So you would just look at the variable or the collection name and dollar field name, whatever you assigned it. You can use that syntax to reference any one of the fields that you assigned in your collection. So dollar name, dollar age, dollar married, and you could also do so with indexes that we saw earlier, but that's less intuitive in lists. You have to remember what index 1 refers to and what index 2 refers to. But it's easier to reference it by name when you're working with lists. The other thing is hash table, and you could use this to specify an environment. A hash table is basically a list of key value pairs, and the value can be accessed via the key. So if you look at some examples here, so what we're doing is we're creating a new environment variable, and its type is a hash table, and we're assigning it to this variable tab. So then we're using this assign function, and we're saying, okay, this is the key, this is the value, and the key and value can be all different types. So you could assign anything to it. So you could have a key of any type and assign a value of any data type, any of the data structures that we've seen so far as well. And you're assigning this key value to the environment variable of tab. So basically you're saying, put this key and value into this hash table, is basically what that's saying. And so there's just 3 examples of this. And when you want to fetch something from a table, you would use get. So assign and get are the 2 pairs to put something into a hash table and fetch it retrieve it from a hash table. To retrieve it, you need to use one of these keys. And then that would bring you back the in this case is just printing out the whole this whole list here that we assigned as the value. And so yeah, this is just basically two examples of that. Yes.
Why would you use that as opposed to just doing a list or variables? Is there a particular advantage for that, or any particular application, please?
Often when you're scripting different things, if if you want something to be global, so it has to do with scoping. So
Okay.
if you have something within your function, the scope is within that function.
Right.
And if you want something just accessible and as a reference in something, so this doesn't matter in smaller scripts, but you have multi-file scripts.
Right.
You could just reference it from one place.
Okay, that makes sense.
Yeah.
Thank you.
Did you have a question? Sorry, I thought you were raising your hand. Okay. Sorry.
So this is like the easier way to like access this particular variable or value from somewhere outside this type of function.
Right. I mean, in most scripting languages, you have this notion of an environment. Basically, these are, you should think of them as global variables that are accessible, that are just available anywhere. Usually in the kind of system scripting that we do, it's usually certain paths, certain certain library paths, so forth. But I think the use of this is analogous to that. To just, if you want to keep an environment, if you want to define an environment for your series of scripts to follow, then this is you would use a sort of a hash table like that, where you can always retrieve it from.
So then you could do that, and then at the end, if there were certain ones that you would want to keep, and you would say assign, and then do that dot global environment.
You would say, yeah, assign it to whichever hash table that you initialized, and
Right.
just put it in there for future reference. I don't think it's I don't think there's any obvious advantage to it. You could have a global list and get the same functionality.
Right,
It's just
right.
I think the hash table referencing might be more efficient. So there might be some small built-in algorithmic advantage there, but otherwise I don't think. Yes.
Thank you.
So when you get something from one of these hash tables, does it change your prompt? Is that right?
It's
So
basically
you say
printing.
get,
Yeah.
and then is it just spitting out all of the values that
So,
are stored in it, or are you typing in ID and then it tells you?
No, I'm not typing in that. So what you see in blue is what it's spitting out.
Okay, so it's,
Yes.
so when you get it, it just outputs the value.
Right. I mean, if I'm typing in anything, you would see a prompt before that.
Right. That's what I was.
Yeah. So what this is doing is you could just assign it to another variable. If you haven't assigned it to any variable, it's like you're type printing the variable name. It's your we'd seen this before. Analogous to just typing in A, and you get this print out in blue. So what we're seeing here is basically you're getting the variable, but you haven't assigned it to anything. So it's like you're typing in the variable name, and it just spits out the whole variable, which is this entire list.
If you were to type like get and then the
If I would have typed C equals get whatever, yeah.
Then also, what if you typed get the arguments and then $ID or something? Would it only give you the ID value? Kind of like how would you get stuff out of the list?
No. The get function would be, you would have to give it a key. So you give it a key.
No. The same argument.
Oh, okay, yeah.
And
And if
$ID after.
after the get,
Would it only return the first?
that should work actually. I haven't tried myself, but that should work. Because you're just saying variable name $ID, so that should work. Okay. So cover that. Okay. So this is perhaps the most important data structure. You would probably almost by default use this. It's called the data frame, and the best way to think of it is like it's analogous to an Excel spreadsheet. And so you could have row names and column names, and so it's kind of a mixture of the list and vector, the list and matrix variable type that we saw, data structure that we saw. But the most analogous way to think of this is what you would use if there's a way you can format your data in a Excel spreadsheet, the data frame is what you should be using in R. And so you could name attributes and column names, And so basically you could name entities, which are the rows, and the attributes, the column names. And you could do a lot of interesting processing once your data is structured like this inside R. And so the first step is getting your data from your raw format into. Do you have a question?
No.
Oh, sorry. Getting your data from a raw format into a data frame, and the built-in function that you have there is it's called read table. So read.table, and the format, it takes a bunch of various formats, and so you can specify what the separator is, whether the data includes header names or not. So that's what header equals true is, and whether the rows have names or not. So what it's basically assuming there is, does your data include these names, or is it just the numbers? Is it just the raw data? You specify the path of your raw data file in double quotes, and does the first row contain variable names? Does the first column contain data label? So this is how you could read it from a raw file, and this would you would take this and assign it to a data frame, basically. So by default, it assumes tab delimited file, but you can also specify that. I think it also takes comma separated. I've used comma separated files before, and it does take comma separated as well. And once you've assigned it, so we're using the old assignment operator. Maybe this is a slightly older slide, but you could just use worms equals read.table and the rest of it. And to see what's in a data structure, you just type out the variable name as before. And so a data frame basically looks like this again. So there are a couple of shortcuts once you have it in this format. You can index into this, and so you need you would need two indexes, one for rows and columns. So one of the shortcuts is when the first index is blank, it just means give me all the rows, and when the second index is blank, it means give me all the columns. And you could use various shortcuts to slice through this kind of table. So an example here would be give me all the rows and columns 1 to 3 of this data frame, and that's what you're seeing here. So the first index blank means give me all the rows. Second index, we specified a range using the range shortcut that we saw earlier, and that's basically saying 1 to 3 serially. So that's one example of it.
Are the
Yes.
the headers and the row names not indexed? Or are those indexed 0?
They are.
Because you get
Yes.
1 to 3.
Yes.
You still have the row
I think they have a. You can reference them by saying. I think there's a call called names that you can reference them. So row names and column names, but I don't think they're referenced by numbers.
Right.
So
the
yeah.
indices refer to the actual elements.
Yes. Yes. Right. Okay, there we go. So, so yeah, if you wanted the list of, I think these are column names. So, if I wanted a list of all the column names, I think there's a names call that you can use. Like that. So names on worms gives us all the column names in a list of strings. And running attach, I think you can access them by name. So you could say worms dollar column name, and that would give you that corresponding column. And I think this example is using logical operators to slice through a data frame. So what we see here is we have the old data frame, and we say give for all the area column greater than 4, and slope less than 1. So give me all the rows with this condition holding true. Is basically, because you're specifying it as the first index, you're basically saying give me all the rows where this condition is true, which is basically area greater than 4 and slope lesser than 1. So you could so we are getting already into things that you are a little harder to do in an Excel sort of environment. Again, so this is again logical slicing through. So you're just saying, give me all the rows where that variable, the Boolean variable damp is true, and all the values in the column vegetation. So there you go. So so you were asking about how to reference by name. So that's one example of it. So that column had vegetation, and so you'd say worms dollar vegetation, and you would get that column returned as a list. Again, give me a Boolean of wherever vegetation equals grassland. So you would get a vector and that's what you have there. The useful thing of using these Booleans is to index back into the data frame. So you would say, you would just use it as a row index. So you would use this condition as a row index, and you would basically get those 3 rows wherever grassland is true. Actually, it should be. This should be true. So I'm not sure if this example is correct, but you should, we can try it out later. Yeah, it should return all the elements where this is true. Oh, sorry, where grassland is true. Right. That's right. I was looking at false, and I got mixed up. So yeah, it's just returning the rows where vegetation equals grassland. So that's right. And you can also index by column. Our examples here have shown mostly rows. And you could do them logically or by specifying a range or any other mathematical function. So you could also sort things in a data frame. One of the ways is we use the order function. And so what this does is, so let's look at it from inside out. Worms square bracket comma 1 is basically saying give me the first column of worms, and the first column is the area, and then you're sorting it. So you're sorting the first column, and then when you have the sorted column, you're using that as the first index. So you're getting all the rows sorted by that particular column. And this is the second index is slicing through, you're just getting columns 1 through 6. So I think there were 7 columns in this data set. So you're just interested in the first 6, and you want them sorted by area. So this is one way to do it. And yeah, So just what I said. And you could also reverse so the default sorting is ascending. You could also do it descending by using the reverse function. And again, the columns are sliced differently. So the second index is basically, you're only interested in the 4th and the 6th column. So you just give a collection of a vector of 4 and 6, and that's all you get. You don't have to do it serially or within a range. You could select on a custom basis as well. So with that, we'll just get into flow control. This is probably similar to every other programming language you've seen. It's very similar. You have so it's basically what you're doing is conditional execution. You're testing a logical expression, and if it's true, you're executing one set of statements, and if it's false, you're executing another set of statements. So it's basically it's an execution branch. The else is optional, so you could just have if. And the other thing in flow control is loops, which is quite common in most programming languages. You have the for loop, which is you're going through, you're indexing through a list. This is the format of it. You also have the while loop. The for loop, the initialization is included. In the while loop, you have to initialize separately on the outside. This is just very basic stuff. I don't know what much else is there to say about these. They're just very basic flow control functions. So if you're writing an R script, you would probably use a lot of these. And
the important thing to mention is once you do loops and loops, it becomes very slow.
Right. So we'll get to the parallel. We'll get to the parallel parts in the second half of this session, and so that there are ways to do parallel fors and things in R. So each iteration of the for would be executed separately. So, but yeah, I mean, you would rather use a matrix operation rather than iterate through something. Yeah. So one thing here, so there's this function called apply, where you could apply it to a data frame, and basically any mathematical, any operation that you think of, you could write it as a function, a customary function, or a customized function, or a built-in function, and you could assign it to every element of a data frame. So let's look at this example here. So you have this data frame that is, there are 2 columns from that data set, and we are hold on. We are applying to so the first argument is the data frame, the data structure that you're working on. I think margin is referring to the column. And okay, so you're applying this function to the desired dimension of the data frame. So this matrix, this data frame or this matrix has 2 dimensions. One is the rows and the columns, and you're applying the sum function according to a chosen dimension. So this is the rows. You're basically summing up every row. So 5.2 plus 7 is 12.2, 5 and 6 is 11. So you're summing along the rows. You're applying the sum function along the rows. And that returns the result as one vector of sums. And you could also sum along the columns. So you will have 2, so you're basically summing up all the soil pH values and the density values. And so you would sum along the second dimension. So that's what's happening there. So you could apply any function along a chosen dimension to the entire data frame. And so let's see the compute row sum. Let's see. Okay, so this slide's basically comparing the timings of applying it directly and trying to loop through it yourself. This is something you can try on your own time. You don't need to spend much time on it, but it should be faster with using the built-in R. It should be faster than iterating through it yourself. Yeah, so proc time is basically a system function. That's there's a high-level R interface to it, which is basically you're reading processor time before you run some instructions, run whatever you want, run the for loop or whatever, and then read processor time again, and the difference gives you the time spent in execution. And so this is just a simple way to profile any kind of to just see how much time is spent in any section of your code. So there are two more important versions of the apply function. One is that applies to a list, every element of a list. The other is applies to a list but returns your data in a slightly different format. So let's look at lapply. Okay, so there. So you're starting off with a function. You're creating a function that returns. You give it a number, and it returns a vector of. So if you give it x, it returns a vector of x squared, and x cubed. And so that's what the function is, and you're applying it to every element of the list 1 through 5. So what you're getting here is for the first element, when this function is run, it returns 1 square, 1 cube, which is 1, 1, 1. So and same for 2. So it gives you individual lists. So the lapply we're looking at is on the right. It gives you individual lists for each element of the original list that it was run on. If you want to bundle these into a vector, you would just use sapply. So it basically takes each of these results individually and bundles them into one data structure here. So lapply and sapply is again you're applying one function to every element of a collection. And again, the way to define a function is give it a function name, say the keyword function, specify the arguments and the statement, and return an object. So these are the key parts to it. Again, as always, we're using the old assignment operator. If you can replace it with an equals to. And yeah. Okay. So the example shown here is a power of 2 function. And so there are a bunch of these built-in functions in R. You could compute the row sum using the of a matrix, and built-in functions are usually preferred, and they're generally more efficient. They're less likely to have mistakes. So you could implement your power of 2 function, but it would be easier to just use the built-in one. The other thing you might find very useful is when you have a data frame, particularly or a matrix, you could actually get summary statistics of your data, and all you need to do there is just just call the function summary and give it your data frame, and you would get various statistics on quantile ranges, mean, medians, max min values of each field, of each column or each attribute types. And this is just like a starting point to do more analysis of your data. But if this is all you're looking at, then your analysis is pretty simple. So quite often what people do is they scan their data into a data frame and just run summary, and then they examine what each they examine these basic statistics, quantiles, mean, medians, and quantiles, and the max min range for each attribute, and then they use that to inform their future what type of analysis they want to do and so forth. And so that's a very useful one, summary. So that's the one you should remember. And so the plotting in R can get really, really complicated. The plot function itself is a very, very rich function. You could, you could study it for days practically. But the default plot types are very easy to get through. And it automatically creates this file, which you can export into PostScript or PDF or any other image format. There are hundreds of options that you can play with on scaling each axis size, colors, background colors, whatnot. You could just go, you could play with it for days and days. But the basic plots are actually very professional looking, and we use them a lot here for publications and things. So it supports many different plot types: histograms, density curves, box plots, quantile plots, scatter plots, and you could do a lot of three-dimensional things. You could do heat maps, and so a lot of them are built in. I think there's also a histogram function. The scatter plot is the default plot matrix, but you could also have sort of a linear plot and style the lines and all kinds of options you have with that. So as you get more familiar with, your plots will probably start out looking like this, but as you get more familiar, you could probably have very nice looking plots with R. Example here is a hierarchical clustering heat map that was shown on some data set. I'm not familiar with the data set, but you could get fancy plots like this quite easily once you're familiar with the plotting function. So the plot function is something that you would spend. It's very easy to use in its basic form, but you would spend some time learning its advanced features to generate some stuff like this. The other thing, as you're working through your script or your interactive processing, you could use a lot of functions to save your work. So if you're working interactively, quite often you would run a command, you would see its output, then you would run another command, and you could very easily go into a chain of things that you tried that you don't remember, and you could just save the whole history like this. And so quite often what I've done is I've used it interactively first and used that first pass to to form the skeletal script, a batch script that I process other data sets with. So yeah, saving history is a thing. But later we'll see, we'll get to the RStudio IDE, and it has a history window that you could just point and click to. You don't need to remember these commands so much. But if you're just restricted to a shell, you would need to use it. It would be good to remember these commands, so you could, if you need to log off, you can pick up where you left off. So so yeah, it's basically what you're doing is you're saving a file, and then you're using save and load to basically pick up where you left off. And the IDEs sort of do it for you, so you don't really, you just open it up and it starts off wherever you go. So this I mentioned in the beginning is when you want to find out about any kind of R function, you could type help command name, and it opens up the manual page for that function. So you could do question mark or help. for any function of R. So you should try question mark or help summary when you get to a shell. And where are we on time, Rishi? You okay? Okay. Okay, so we also find that R is very useful as a data analysis tool because, as we've seen, it has very rich plotting functions. It can be used for, it has a lot of good support for visualization, easy way to clean your data, to transform your data, and easy way to sort of batch process your data. So there are some data mining methods that we can just quickly go over. A lot of them are supported in the core R packages, or a lot of them have their own separate R modules that that are supported by the community. So for clustering, there's a k-means clustering, which is a common clustering algorithm. There's a decision tree. So there's a R-part library to support that. There's a class for the k nearest neighbors, and many other common algorithms run in data analysis. The most of the libraries come as a package installation as part of the core, or you could use the library call to separately include it. So the library is sort of like you can think of it like an import function in Python or an include in a lower level language. So this, if a library is available, this is how you would import it in your script. Yeah, and at the R point, if a library is not locally available, you could install it by using the install.package command. And there are many. You would almost always find some package in the R community that would support it. So the CRAN R project is basically the comprehensive R archive network. I think that's what it stands for. It's basically a collection of R packages that are continuously maintained and supported by the community. So we can step through an example of cluster analysis. It's basically you're trying to find, if you have a data set and you're trying to find clusters within them, you're trying to find various groupings within your data, since your data would not always be uniformly distributed. And you're trying to find what clusters exist and draw some inference from that based on your domain. What the general property is of a clustering algorithm is you're trying to maximize the distance between your clusters, and then you're trying to minimize the distance within each cluster. So that's essentially what defines a grouping of within your data. So k-beans is a very common algorithm used for clustering, and it uses a geometric centroid approach. What the what the algorithm looks like is basically you're assigning a point. You first pick some centroids as the initial centroids, and then you assign a point to the nearest centroid. So it starts off with how many ever centroids, how many ever groupings you want. Hold on 1 second. Slides are, yeah. So if you want to start out with k groups, you would initially just pick k centroids, and you would assign the rest of the points to one of these k centroids. So you get an initial group of k. And then how it works is you recompute the centroids based on those groups, and then you reassign. And based on, because the initial points are static, you would get to a point where you converge on a set of centroids, and the centroids don't change thereafter. And so the algorithm is actually very simple. You just step through it like I mentioned. You pick k initial centroids, you assign the rest of the points to one of these k groups, clusters, and then you recompute the centroid of each group. And then you just repeat this process until the centroids have not changed. And so various iterations of this look like so when you plot them out. So here we see we have three clusters we configured. So we initially chose 3 centroids. And at the second iteration, centroids moves a little. Some points go from one group to the other. And the third iteration, 4th, 5th, and I think there's a 6th too. Yeah. And then you finally converge on a grouping. And this is a way just to find grouping in the data. And so this is another example with 2 groups. And it has the built-in k-means function. Will give you some, I think, means of each group. And I'm actually not familiar with this second example, but we could play with it if it exists in our data set. Yeah, so the CSV file has a bunch of data points, and the clustering vector is basically telling us what each point belongs to group 1 or 2, and that's what you're getting with that. So that is the output of the k-means function that you're seeing, and yeah, and that's just an example with 2 groups instead of 3. So and the k-means function gives you some of these extra statistics on each cluster. And so these are just showing various packages available in the CRAN database. So it's a very, very mature collection of packages. So you would almost definitely find whatever you're looking for. So with that, let's get to the R Studio. So using R on command line, even though that's the traditional way it was used, it's a lot easier to use an IDE for it. The history functions, and quite often you would find that you would be cutting and pasting a lot of previous things. For instance, like a plot, when you're trying to tweak a plot, you would just be using almost the same function, changing minor things. So you'd find the RStudio IDE very useful for this. Also, it lets you run interactively and also build a script at the same time. So that I find that really useful. So what happens is you would try something, see the output. It has a separate plotting window, so it sort of looks like so. So it's not very clear here, but it has one plotting window and it has one interactive shell where you can keep trying different things. And if it affects the plot, you can see the plotted output. The top window on the top right basically shows you the list of variables and the environment, and it's basically like sort of like a history. And at the same time, when you're trying out things interactively here, you could also be developing a script. And you could do this across multiple files, multiple tabs, so forth. And so the plot, for some of the plotting, you can also change some options here, save the plot. There's a lot of things you could do with it. It's just a lot easier. You can get a lot more mileage out of this than just a command line prompt. So we'll have you guys try this out on through the Viz portal later. There's also a useful function that you'll see here is when you click on a variable name in the data viewer, you could actually, it could format a data. So what we're seeing here is a formatted data frame, so you can also view your data in this way. Yeah, I think it has package management built in. So when you want to install a new package, here we've switched from the plot tab to the files tab, so you can sort of navigate through a file, find a file, open it up, run it, so forth. And yeah, this is the variable environment viewer. There's also a history window we were looking at before. So the history will basically show you the list of commands, and you can copy and paste from and through these windows. So it's actually very easy to build a script when you're trying things out interactively here. Yeah, also, so there's a basic functionality of saving your project and so forth. But this is all very intuitive. It's much easier when you're trying it out, and we really don't need to comment on it much. You could try so the prompt here will you could try your help functions here, the question mark or the help for any R function, and you would have a nicely formatted manual page here. In the prompt, you would typically get it within the same window in the shell. So this is a good way to just quickly see a documentation of a function and kind of resume working, and work while you have the documentation on the side. So I think we are at the point where we are going to go to the Viz portal and have you guys run an RStudio session. So just give me a minute and I'll coordinate with Riju and we'll start on this.
Designations not working through the on-screen piece. The
Really?
RStudio, yeah. So how many of you have the RStudio on your laptop? So almost everybody.
Okay, who doesn't have?
Who doesn't have?
3. You too? So 4? Okay, 4.
Only 3.
4 of them.
No, that one is from tech.
Okay.
So for those who have RStudio on their laptop, just use their RStudio. So there's some problem launched RStudio in the reservation right now, and then we will fix it. But basically, all those exercises can run on your own RStudio right now. So you just can try those exercises on your RStudio in your laptop.
How do they get the files?
The file is in the directory, okay. So I'll show you. This is the when you log in the Stampede. Oh, sorry.
And you run batch.
Sorry, what is that?
And you run batch.
Can you run batch?
Yes. Instead of having to go to RStudio.
You can. I mean, RStudio is more for development. So when you're building a script that you can run batch, yes.
So I think you can. There's only 2 nodes available in the Viz queue. So probably those who don't have RStudio on their laptop, they can use the Viz queue to log into the Stampede.
Just asking if
Yeah, she can do that, and then the other one can do that maybe.
No, I think she wanted to know if you can run batch through RStudio. It's not really meant.
It's an interactive section,
Yeah,
so you cannot do that. So you just finish your code, and then use the rscript command to do the batch.
Yeah.
The only way to go into something to run R is if you go to RStudio. Is that what you're saying?
No. We have the Viz portal that lets you run R RStudio on Stampede.
Okay.
But they're having some, you need a reservation for it to work, and we're having some problem with the reservation.
Correct, but if we don't use our studio, so what are the other options?
Just R on command line.
You can do it interactive too on the.
I don't think how, I mean, because right now.
And you
they-
can
it's
Yeah.
asking us
help her
log
to
into the-
log into the Beats queue, but not without the reservation.
We don't go that
So
route.
there are only 2 nodes left. So probably 2 people can use the RStudio.
We have a reservation.
The reservation didn't work because it's setting to the normal mic queue. So right now it's not working. So
We have 60 nodes reserved, right?
yeah, but it's already reserved in the mic, the normal mic queue. But
Okay.
no mic queue cannot launch the RStudio. So there are only 2 left in the Beats queue without the reservation.
Okay.
So you can probably have
Okay.
2 people to log in
Okay.
using the Beats without the reservation,
Okay.
reservation ID. So they can use RStudio, but for
Okay.
others, they can use their own
Okay.
RStudio.
Okay.
Sorry about that. So for the exercise, you actually can run the code on stem P. Oh. Fine system. So just ss to the stem P dot tag dot utexas edu. Everybody can see?
Should I use my, since I have an XC account, should I go in that way, or just, okay.
You can go through the MC login as well.
What's that?
I mean, if they have their own allocation, this class was set up, the training allocation is set up. So you can use it if you already have one.
You guys allocated some issues or something.
Yeah, we have 2 different allocations. We have an exceed allocation and we have a TAC allocation. And the TAC allocation is set up for both Stampede and Maverick and other TAC resources, but the exceed allocation.
So you all finished login to the Stampede? All of you?
Has it changed recently?
That's, we just have to route the allocations to us too, because the way that the registration works. The registration works, they go through the TAC user portal, the username that I captured
And then you just CD to the directory in the
is on the
PowerPoint.
I think that looks different locations.
So this is the directory. Just CD to the directory here.
Should we make a copy of it into our own work directory? Or
You can copy it, or the directory has
are we
some
all gonna run the
file.
same code thing?
So the code is called r introduction.r. So actually you can copy the code, or you can Actually, you have to copy the code. Cat R introduction.R. These are all those introduction exercise. You can copy them to your RStudio to run it. So you have any problem, just ask me. So following 15 minutes, probably you can use it.
Logging. Can you quickly tell how you can use it?
So you can log in stamp here.
I don't remember that. He doesn't remember the password, so.
Password. So ask Jason maybe. Where is Jason?
There's supposed to link to set the password. But you need to know what's in the email address.
Yeah. I know the user.
He forgot the password.
You can't log in.
You get that.
So that's the directory here. So you can cd to that directory. And then the file to practice to do the exercise is R introduction.R. So actually you can copy the file or just cat the file and then copy those scripts to your RStudio on your laptop. So you have any questions, you just ask me, so I'll help.
Oh, yeah, I can't create this.
So this script basically cover like data type and loop and basic data structure, and then some functions and data input and output, and then simple plus. So for those commands need to read tables, the table is within that directories. You just can copy those, like the worms.txt. Using the scp command. If you don't know the scp, how to use the scp command, just ask me.
Sure, please.
So in the R introduction file, do we have to do anything?
You don't need to do anything, just run it to see you can understand it. There's some questions or like quiz at the end of the script. So if you can understand, you can do those two questions at the end. So the R attack and parallel R is starting at 10:30. So those who are online and don't want to practice, just take a break.
So I sort of copy everything on my local machine. So I need to update the source directory.
Yeah, so you just use your own
Yeah. So when I
just delete them.
do,
Or you can set your working directory.
do you have it? I highlight this section that I want to get rid of. See, it's like deleting from somewhere else. Is this like part of our studio or? Can you close it and open it again? Oh, it's really good. Yeah.
Yeah, just type it once. Seems the pointer is not.
Yeah.
The slides.
Yeah, it's weird. So I should be able to delete this one. Just save this one. Close it and open it again. Well, I don't think that'll fix it. I mean, that
Just the pointer is there.
how do I run?
It's not live.
Oh, it's,
And also, so it's not just directly, you can use the scan. And get WD.
what's this gonna do? I need to fix this.
That's your home directory, so you should put the file.
Well,
It's too slow, so you have to fix it.
I know where it is.
So for some people who have never used RStudio, so I'll show you how to use it. So RStudio, launch it, and then open a new RScript file, and then just copy the script. To the RStudio, and then going to the top. If you want to run the command, just click the run button. They will run line by line. Just like click, and then we'll run the library parallel, loading the parallel package. If you don't have the parallel package on the directory, you just use the install packages, and put in the parallel. Install the package. So that's the way to run the R command. Just click the run button, will run line by line. If you want to run all, just click, select all, and then run.
I have one question. So I don't understand exactly how the RStudio now works in Stampede. You have to go through the visualization, it doesn't work. Is that how it works? Or if I have RStudio installed, I can actually run it on Stampede?
So there's a issue with the keyword reserve. So
I
that
have to
one.
go through this.
So do you have the RStudio on your laptop? So you just use the RStudio on your laptop for now?
No. What his question is that if he has RStudio locally, is there a way for him to still run on Stampede?
No,
Is that
there's
right?
no any connection between your local RStudio and the one on Stampede. So on Stampede, just
With Revolution R?
the RStudio is developed by the Revolution R. So Revolution R is the developer.
Okay, the Revolution R is a little bit faster, right?
Yeah. There's a specific patch
Right.
they develop within that.
Right?
Yeah.
Is there any compatibility there?
You can try, you can test, but I don't think there's so many difference between these two. So you just use the RStudio, that'll be fine.
No, it's very good. It's very good.
Okay.
I mean,
I never used the Revolution R.
I think they're compatible with like the HP clusters.
Okay.
And it will actually automatically do the distributed computing for you.
Okay.
So if you use Revolution R on like an 8-core workstation, the academic license is free, by the way, for us, but it goes up to 8 cores.
Okay.
But there's a professional version that actually will distribute it. And you don't really have to parallelize your code, right? You
Okay.
actually distribute it across the cluster.
Yeah, that's interesting. I never know that. But
Okay, there might be something to look into.
okay. Yeah, sure.
It's not free, then we can't offer.
Yeah.
Yeah, 'cause you get a license.
If you need license, there will be trouble for us.
You assess to everything you pay, and you get it, so that's normally what we do with that. You have to bring your own license, do your own license, because we're not allowed to do that. We're all.
But how do you do it, how do you launch it?
But our students in that start, this is free. We can't like, it's on the new license.
How do you do that?
We can distribute. The
I know.
commercial package is like really hard, but to manage.
Yeah, well, the Revolution R, the academic version, is free. So for everybody to do.
It's like a class, there's no way we can tell. What
Yeah,
are
I see.
you having or that's your user.
Oh, okay, we
And
should.
it doesn't know how many points it is.
I don't know. This package, it is a library. I don't know, it's a library also.
Yeah.
That's not it. I just need to know.
Yeah.
Oh, yeah. So, who is the R expert now? Because I used to work with Jakub.
Jakub?
So he left.
He left.
Oh, Jakub left?
Yeah.
But he was not really an R expert. He was very kind.
Yeah.
Trying to figure stuff. But who is the contact person nowadays? Is it you guys?
Contact person, you can send the.
But is there like a, are you guys the R experts? Or
It's easiest way to say.
Yeah, send a ticket to data intensive queue. You have any problem?
Okay, no, because Jakub told me at one point, he asked me if I knew someone.
That's fine. I'll close it and.
You are very well and you knew like supercomputing and all that. But I thought that they were trying to hire someone.
We have some like in-house expert. That's the way you get hold of them, just entertain. Now, we'll get hold of those people. We'll see what's about this now.
That's fine. Yeah, which one calls left?
He's a good guy. Ready to go.
It's serious PhD. Just going to his PhD.
Good.
You may say you come to.
Yeah.
Is there a way to use some kind of external standard
is
to have our studio?
So we define this licensing already.
Okay.
Which is a list.
Yeah, that's right, you do it.
This is just your example.
That's right, but is there a way to?
It's like, I guess SSH
J
is
is
minus
equal
X.
to this and
Right? If you see X Windows, right, yes,
Yeah,
right,
yeah.
and then you run our studio.
Yeah. We install on your account. You can either use our
So,
one or you
yeah, it'll
Because if I use, if I
True,
use
false,
just
true,
like
false.
say
Is this printing
SSH I cannot run.
elements of line missing instead of non-use trying to missing to avoid understanding instruction?
Right.
Yeah, so J tells you if the elements are missing or not, this returns the
Okay.
back or as non-missing.
I give 2 hours for full access to that
No.
computer. There's no.
J is
No,
a list of points.
Okay.
There's like 16 cores now.
16 cores.
Power.
And then you get 16 cores and then you can,
Yeah, you can SSH with minus X or minus Y option there.
okay,
That's I don't know.
okay,
Don't do this on the login.
No, I understand. So J is a list of points.
You actually can, but the way
So
I
it takes
take
time
my
to
back
scan.
end.
Is one missing? No. 2 is missing.
You got login now.
3 is not.
Share.
okay,
So
so
now-
you
So now we're returning the elements
Okay.
of line missing,
They have a reserve now, it's either like that or.
not
Or
missing.
it's just- that's right. So 2 hours.
2 hours max, okay?
then.
So-
You're talking about the second one, you're indexing using the
Okay.
So then,
Yeah,
what is
right.
returning on
From
here?
there, then you run
What is
any
log
Okay, okay, any GUI based.
Oh, logical,
Okay, I
there's
see.
3 elements.
Yes.
Lost your place, that means-
It's good enough.
It's basically
Yeah, yeah, so these are
Like
these are the
a-
names.
Our thing
This
is
is the type.
It's so better, yeah, and if I send it to you later, you code, right? Oh, it's same code, right?
Yeah.
So why doesn't it tell me my numbers and number?
Oh, this is 24.
I think that's native to
This is 24. We have to treat right into sector.
It depends on the queue.
Oh, okay.
So the normal, the normal queue is 48. The biz queue is $8. GPU is 24. Normal dash mic is 48.
I think it's just the
Normal
same.
dash 2 mic is 2 mics is 20.
I've been running your stuff.
Just remember.
48 hours. Probably about that. Yeah, so that's how it goes.
That's what we do.
Yeah,
Yeah, we do it on
bootstrap.
days.
Right.
So you just save it every 1,000 iterations.
Right.
And then when it's, you know.
Same time, you
ready
want
from
to
there.
set to alter, right? It's a lot of calculation.
It took us a while to really optimize the code because we were sending too much data. Yeah, and so, what was the library you used for the case? Remember? Was it the cluster of line?
Custom.
Yeah, what was the library? It was one parallel.
Oh, the memory we use is snow.
Snow, yeah, we used Snow, you know, Snow?
Snowfall.
Yeah.
Right.
Do they do?
Yeah, Arizona's way to do that more than I
But then, I don't get.
Yeah, the trick was to really send all the data to the nodes and store it there.
R was not designed for API line. Games, that's the thing. I believe in the first place, it just not to like for.
Okay,
Yeah.
it's time to get to the next part. So for those who did not finish the exercise, they can continue at home. So it's pretty straightforward. And if you have any issues, you can send us ticket. So the second part is about the RStat modules attack. So somebody always send us ticket, what's the difference between RStat and R? So RStat actually is the R, but compiled using the Intel compiler. So there's basically no any significant difference, but the performance would be much faster than the R itself. So when you have some jobs running like days and maybe like hours, and probably you have to consider moving to the tech nodes and using some automatically offloading with multi-core or GPU or mic card. So I won't cover the GPU and mic card today because probably we don't have enough time. And then these two topics.
Are you gonna do this, because I was actually here to hear those details. Are you gonna do another session at another time?
Yeah, we have another sections in November, right? Probably David will cover these two, like GPU and mic. And you also can read these slides. They have enough detail for you to get into these two topics.
Yeah, I think it would be a good idea to because I think a lot of people know R, right?
Mhm.
Like one that really deals with.
Yeah, because today is like a beginner level, so everybody just like getting familiar with R basic. So we don't want to go into too advanced topics. So
But in November, you will have a special session.
yes, we'll probably get advanced sections for that. So how many of you like very familiar with R here? Okay, how many of you familiar with parallel R, like using multi-core Snow and
So,
for each loop? Okay, you should go to the advanced sections. you should not come today.
You tell me now.
Yeah, because when you see the other basics, actually teach like basic R stuff, and then
I thought there was something new in our studio.
yeah, we have more advanced R teaching like Hadoop and Spark. So if you have some interest, you can come at that Spark R and then Hadoop. So for tech resource, we have several clusters and the Stampede, Maverick, and Wrangler. So Wrangler basically you can run Hadoop and Spark on these clusters. And for Stampede and Maverick, these two clusters are pretty similar. And so probably the detail you have to look into is the how many cores per node. So you have, and then how many memories per nodes, because when you run the computation, you use the shared memories. So you have to know the resource you have to think about how many process you have to spawn.
Is that cores or nodes?
Here's like 16 core per node, and then 32 gig memories. So you can check the Stampede users guide. There will be like listing how many cores on the Stampede and how many nodes that CPUs. So a dual CPU, right? Yeah, it's dual CPU. So each CPU has 16 cores.
8 cores.
It's 8 core? Okay.
You have 2 of them.
Okay. I don't know, David writing this here because I substitute for this like lectures. So, and so how many of you familiar with Linux commands? Okay, quite a lot. So if you want to run the RStat, you have to know some basic Linux commands on Stampede. And since most of you are familiar with Linux, so you can start. So everybody already logged into Stampede right now. So you just use the module list here. That's I put it here. So module list, try it. And then you can see those default modules already loaded. On the login node. So you can see there's no any like R or RStudio. So you also can use module purge. You can remove all modules on your calendar node. And then you can load each module. So this is the way, and then so if you want to load also you can use the module spider, RStats. So you can see there's 3 versions of R available. So the latest one should be 3.2.1.
Do you know when we're gonna get the new one by any chance, please?
The 3.2.1?
There's a 3.2.2.
Oh, you can install in your home directory by yourself. Yes.
Awesome.
I will teach you how to install on your own directory later in these slides. So if you want to load if you use the module spider RStat 3.2.1, then you can see it's actually compiled using the Intel 15 here. So that means.
If we get your slides.
Do you, Jason? Do you send out those slides? There's a dumb drive.
Okay, just great stuff. Can you email it? Oh, you want to?
So if you want to load the RStat 3.2.1, you have to load the Intel 15 module using the module load Intel 15. Then you can the latest version, not the latest, but pretty latest, but 3.2.1. Then you can load after you load the Intel 15. And so I can say, so here's when you load, after you load the module, there will be the RStats 3.2.1 and together with the Intel 15.20. And then when you type R after you load the RStat module, if you want to install the package, actually you cannot install into the system directory. You only can install on your own directory. So you just type yes. When you ask would you like to use a personal library instead, just type yes, and then they would install the package in your home directory.
And it's the current directory that installs it, right?
It's a default package we set, so it's like a path, a long path. So you can see here, it's like your home directory R and then x86 like 64 unknown Linux GNU library -3.0.
So it's a good convention to just.
We already preset it in the spec file. So in the
I used to use my own directory.
Yeah, you can do that.
Can you use a specify your own like installation?
Yes. You can define the R library path using export R and then underline lib lib, or in caps should be, and then equal to some path. Then when you will set the path as the first choice when you install the package. You can set it outside of R or inside of R. There's two ways. And then install. This one if somebody wants to know.
Yes.
So it's pretty simple, I would say. Like you just want to make a directory. You want to install those like lib folders and bin folders. So just like make a directory custom R3.2.2, and then cd to that directory. Oh no! If you want to put the bin and the lib, you have to use the prefix. I will talk about it later. Then you can use the wget command that will download the tar file and then unzip the tar file. Probably you don't need to unzip. Save it. Yeah, you should tar xvfz and then tar file, and then cd to the directory. Okay.
So sorry to go back a bit with the library. I actually just tried to install a library, and it actually does install it in the current directory. It's not from the home. At least on my account.
What do you mean?
So if I install it in the library,
Uh-huh.
and I just follow the instructions, I don't put a path in there,
Uh-huh.
it will actually not go from the home directory, it will actually go from the current directory, make a directory R from the current.
Right. If you're on your
So
your own
it's
laptop.
probably a good convention to just always use the same path, so it's not dependent on, which folder directory you're in.
Okay. Yeah.
There's been there's a Cornell virtual workshop thing. If you look on the TAC online website, or where, no, you look on the HPC Training. And there's a Cornell virtual workshop, and they have some stuff in R, and they tell you how to do the install packages, and they have a whole little thing about installing packages, and you can set your library. They tell you exactly what to do.
Yeah, no, I figured it out already, but just so people know, I think it's probably good to actually point. So if you just do ~ install packages, it will tell you what the specification is, and just always use the same folder.
Same thing,
right,
yeah.
to install everything in the same. Because in my case, it became like really like all over the place, and I didn't know what was where.
I think you also can specify the path you want to install in the install.packages.
Yeah,
So
yeah.
it's
There's
pretty
also- that's what I
it's
meant.
pretty simple. So. And then the most important part is the configure, just like ./configure, and then the prefix would be the directory you put the bin and the lib in. So and then run the make install. There'll be.
You can do that without being super user to make install?
No, you don't need to be the super user because
So when I've done it on my Linux,
because you
I
are
always
on
have to-
you are in your home directory, so
okay.
everything you like running or install will be installed in your home directory. So you can try it later.
Thanks.
And there may be some problems when you program some like something like X line or some other. So you just don't set it to no or set it to false. So there will be pass it. But when you have some problem, just Google it. Somebody will tell you like how to set those flag. So basically pretty straightforward, unless you have some problem. So after you install your own R or the latest R, then you have to set the path. The path should be the first one when the bin folder. You have to put the free as the first path before every other path, and then just you can use your own version R in your home directory, because so many people sending us tickets about I want the latest R because the latest R support my package, and then because it's very hard for us to like sending out those new like RPNs and then to build the R through the clusters. So it's not very convenient for us to update very frequently. And also, when we update the new version of R, somebody will say, "I want the old version of R because my code didn't work with the latest one." So there always like argues about how we should do it. So probably you can install your own in your home directory. That would be the best way. So from now on, don't complain about we don't have new version of R. Because you can do it by yourself. So based on these slides. And the parallel R, so probably somebody familiar with it. So you, only 2 people, I think a little bit. So only 1, okay. If I have time, I will talk about the uploading using mic and the GPU. If you want to learn it, I can send you some materials, some example codes, because I am very familiar with these 2, but I'm not sure I can teach them within time limit. Yeah, sure. You can leave me your emails, and I can send you those codes. So for those who need it, just send me like requests, so I can send you all those like code and exercise.
I'll come back in November too.
The lecture is not necessarily the best way to learn it. The best way to learn is practice. So.
Amen to that.
Can I ask you a quick question? How is Parallel different from Snow?
Using the Snow package and
It is using
yeah,
just
right.
wrapper around it. Or user friendly?
Yes, especially when you only use one node. But if you want the multi-nodes, you have to use the Slum script, the job submission script. Do you familiar with that?
Yeah.
Okay. So if I can see, probably do it like this. Everybody can see it? Okay. So for parallel part, it's easy to do it because you only need to load libraries. But the most important part, you have to know the resource you have, how many cores and how many memories you have, because within one node, the memory is shared by all process. So I have to figure out how many process you can spawn at the same time. So for the first one, you have to define a function like this. I think I have the example codes on Stampy, so you also can copy it.
This PDF wasn't on the USB drive, right?
Yes, I sent it this morning. So
Yeah, it's called rtag.pdf. r/tag.
but you can
It should be on this one.
look at those previous training. Okay.
Yeah, I've used it.
The R subtax PDF that I have are just the presentations, not
Yeah.
not this file.
Can you copy, Jason? Can you copy these slides?
It's on the USB.
Okay.
That's going on.
It's on the USB. Okay.
Oh,
Two PDF.
okay.
So for those codes,
You want me to email you?
I think we're passing it. Right?
if you want to copy and paste those codes on these slides, you just go to the R training, the directory, and then go into the R HPC, CD R HPC.
Okay.
The LS should be parallel R dot R. Okay. See, I got an email about these photo issues.
That's it. It's the parallel R.
Yeah, and then you can cat to see what's inside it. Basically, you have all those codes can run on your local machine. So yes, so the last one would be for each and do yeah. So all these examples can run on your own computer, so it doesn't matter which RStudio you use. So you just go into the directory here. I type the directory. So that's the directory. You can get those example codes. Then you don't need to copy and paste. So I'll stop for a few minutes for those people to copy those slides. So everybody get the slides, right? Okay, and continue. So first we define a function which just randomly generate a normal distribution numbers, and then sleep to 2 seconds, and then they'll return the sum of the vectors, and the size about maybe 10 or 100 million. So first we assume you're working in a 4 cores and 8 GB memories computer. Then we should know the memory and the process limits. So this is a sequential code, so sequential function. When you if you want to call the function, you just use the function name, the my process here, and then put the numbers here. You can change the default number size, and then we can see the runtime for this function is about 7,000 seconds. Oh no, the sum, the return sum number is 7,000, something like that. And you can use these two. One is the PTM time and then process time before the function, and then use the prod time and then minus the time you get before it, and then you have the runtime for this process. It's about 10 seconds to finish the function. And then you also can get the process ID using the system.getID command. And this line is actually showing the whole process, the memories and all other process. And then that's your user's name. And when you look into the next page, you can see there's only one R process at the bottom. So it's And you were looking at the top, the RES is actually the memory used, and the VIRT is the virtual memory. So it's about 800 meg memories used for the process. And because the for loop is not very efficient, we can try it first and use the for loop to run the function 10 times. And then we time the runtime like 28 seconds for running it 10 times. And it's not actually the 10 times of the runtime for the single process, actually less than that. And run the same code, you can get the runtime for these 10 iterations. Then you can only see one R process. And then now we get into the parallel part. So for example, if you have 16 core, and then you only have some kinds of like previous memories, like 8 GB memory. So you have to think about what's your plan for those, how many processes you can launch. So also you can try the apply function to actually replace the for loop. You actually run faster, a little bit faster than the for loop, because you use the vectorization. So there will be
Are you still running on one core?
yes,
Just that little bit.
just a little bit fast.
Just go a little bit.
Yeah, but it's just running on one.
Yeah.
So for example, if we have the system has 16 cores, and then we need, so each process needs 800 meg, so it's total like 12.8 gigabyte. So that is larger than the system we defined before. We assume that system only have 8 gigabyte, so that means you cannot launch 16 process at the same time, because we assume the system you have only have 8 gigabyte memories. So it's out of memory if you run 16 process at the same time. And that means we suggest you request only 70% of the entire node memories instead of all the memories. So
That's why it is.
because each process you need 800, right? So the total would be
70%, why not 90?
you can get 90. It's not like a rule, but you probably get 70% will be more safe for you. You can try 80 if you does not give you like out of memory. So for the 16 core case, so you can calculate by if you only have 8 gigabyte memories on your computer, you times like 0.7, and then you can get 5.6 gigabyte, and then use the 5.6 gigabyte divided by the memory needs for each process. You can only run 7 processes at the same time simultaneously. So for parallel package, the first one you can use the MCL apply. It's very straightforward. You just load the parallel library, and then you don't need to change a lot because you already know how to run the apply function, L apply function. So you just apply the vector here, 1 to 10, just like 10 iterations, and then put the function here, and then the process here, and define how many cores, how many processes you want to run it. So that's 4. So when you looking down and the output, so you see there's one main R process, and there's 4 processes running together here. So that means you're actually running parallel. So it's using only one line, and then just adding this mc.cores. So it's pretty similar to the L apply function. So it's pretty simple and straightforward.
So now it's like looping through, it's doing like 4,
You're actually doing
5, 6, 7, 8.
when you look at the runtime, actually like 8 seconds instead of 28. So that means because you request 4 cores, you can only run 4 process first, and then run the second half like 4 process, and then the 2 left.
Yeah,
So
okay.
that means why you get like 8 seconds.
Cycling.
Roughly divided by 3, 28 divided by 3, but 7 seconds, more than 7 seconds. So you can get the idea why you get 7 seconds. Because the 10 iteration will get like 28 seconds. So you divide it by 3, so roughly like 7 or 8 seconds. So it makes sense to everybody, right? And there's a snow package. So using the snow package, you can do multi-core or multi-node parallel. But for the multi-node parallelism, I suggest users use the MPI rather than the socket connection, because the socket connection you have to set in more environment variable than the MPI one. But for the MPI version, you probably only can run under the Intel 14, because there are some issues with the Intel 13 and Intel 15 right now. So I'll show you the example later. And you can copy the codes like require. So the require is equivalent to library. So library and require, they're also loading the library. And then you just replicate the local host 4 times. That will give you a vector of localhost, like 4 local hosts. And then you made the socket clusters. And then you need to export the functions so that each node will know you have defined a function called my process. And this is much more complicated. And then just doing the same thing as the MC calls, like definitions, you do like 10 times, and then timing the duration for the runtime, and then also you can get.
This is socket, right? But
Yeah, this socket.
MPI.
The MPI you can use MPI on your on multi-node also, but the socket is very convenient for multi-core right now. Yeah.
We did MPI. We did MPI. Socket was better. Performance wise, which one's better? Socket or MPI?
I think I tested within a node. Actually, the socket is a little faster than the MPI.
Interesting.
I don't know why, for now.
So what version?
Vantage. I think it's Vantage. Yeah, low.
What's the difference?
What's the difference?
MPI and socket is briefly.
Using the socket connection, you actually use the Ethernet, and then use the MPI. You actually use the infinity band. So the connections between nodes is much faster using the MPI across nodes. I have tested. It's like at least 50% faster than the socket. I remember.
Well, MPI across nodes is fast.
Cross nodes MPI is faster.
But he said actually on socket it's faster.
And socket is faster. Across nodes.
Intra-node, one node.
Within one node.
Socket is faster.
Oh,
Within one node. The
Socket
across
is right. Socket is okay.
I tried it on one node. The socket actually a little bit faster.
Use Ethernet between nodes.
Between nodes, you use the infinity band would be faster because the MPI use the infinity band. So.
But you don't have the additional environment have set for the settings for MPI.
No, we already said it. I would give you an example after the lecture. So you can see the runtime is also equivalent to the previous one using the MC apply, the multi-core apply. And then there's no, and then for each is more convenient because everybody knows the for loop, right? And then the for each package, actually, you don't need to change anything for your for loop, and then you can do the parallel. You don't then need to change your script. You only need to add the do part here, do part function here, percentage do part. If you only put the do here, that will only like running in the sequential version. So you can test the code first using the percentage do and the percentage. That means only run the iterations sequentially rather than parallel. So if the code actually can give you result you expect it, you just like put the do parallel here. So actually it stands for do parallel.
What is the dot combine?
Dot combine, you don't know? So dot combine is a combine function. You can put the C, that means concatenate.
Okay.
So finally you have something you don't know. Finally you have something you don't know. So you already know something. So you get something from this class, right? It's not like you didn't get something. You can also, the dot combine can put AP functions. You can put your own defined functions. You can define a function A, B, and then the function within that is A plus B. They'll give you like the sum. The easy way to like sum the vectors from sum the 10 vectors from the my process is like all those vectors values from the my process. You can put the dot combine equal to sum. That you sum all those values in the vectors together. You can also put mean, also put standard variance SD there. So they will return the final result convenient.
So you said you don't put do par in varies in the code when running serial mode.
Yes.
So you're gonna run 4 copies with the same code, or?
No, you only run each iteration. Run one iteration first, and then run the second iteration in one code, and then one process. Not going to. You only spawn one process if you only do not put the paths there. So it's similar to the for loop, equivalent to the for loop. So if you do not put the path here, you 28 seconds. So, and here is another version of parallel using multi-core. And for this one, you don't need to do the export my process functions because you're using the make connection, and then you just, this one is the different part. Raster does node clusters. You automatically copy the functions to each node, and then each node will know the function already defined, and they can use the functions in the for each loop.
So you would share also data, everything.
Yes. Yes. And multi-nodes, that'll be the one interesting here. And for this one, may not work because using some socket connection. And then you have to setting some environment variables. So it's more complicated than the MPI version of multi-node parallelism. So for the RMPI's node, it's actually using the MPI in R. And then they have a binary within the R package. And I can show you the example code. You can do it right now. But how many of you familiar with the submission script? Only 1, 2, 3, only 3. So I'll talk something about that. So actually allowing you to submit your R script at the logging node to the compute node. The first parameter here, the parallel, is the job name. You can define any name you want. And the -O actually is the output file names for those outputs. And the -E actually output those like error message into these files. And the .O %J, we actually attach those like job numbers at the end to this file, so you don't replace those old standard output and standard error outputs in your home directory. And then the little n is the total number of MPI tasks you request. So that's why you have to thinking about how many cores you have on each node. That means you can know how many processes you can launch. And the -p is the v's. That means sending up to the v's queue. And probably you can, I don't know how many queues you can send up. But for the t, it's actually defined the hours and then minutes and then seconds. You have to estimate how long your job going to finish. And for the standard one should be 48 hours, right? On Stampy, the normal queue, and 48 hours. If you run your job more than 48 hours, you have to send us a ticket to request maybe more days. But that means your code is not very efficient. So probably the first thought should be change your code more efficiently rather than request more hours.
So that's 30 minutes, right?
That's the hour, second, and
So it's
hour, minute, second.
That's 30
That's minute, 30 minutes.
Yeah, the default write is 30, so you usually run it.
So you can just write 48, 0, 0, 0, 0.
Yep.
48.
No, write every
And then the -a is the allocation name to charge job. So that means this will charge your SU. And setting environment. So here, if you're running the RMPI job, you should purge all the modules and then module load the tag modules that's necessary. And then also you have to module load the Intel 14 because you only run under 14. I don't know why, but actually doing that. And then that's the directory you want to put those outputs and errors. You can cd to that directory. And for MPI jobs, also if you do not use the RMPI node, there's a package called RMPI. So you want to run MPI, RMPI, you also have to run under Intel 14. And using the IB run.
I use the 15 and it's working fine.
Really?
Yeah.
Using the RMPI?
Yeah.
Okay.
Are you gonna turn me?
Maverick or Stampy? Which machine? Stampy? Okay. So Intel 15?
Yeah.
Okay. I would try. But for the RMPI, no, I tried it, but it didn't work on Intel 15. You can try. So for the RMPI, so everybody can run those examples and then test a little bit on multi-core, and then there'll be an example on my home directory. I would give to you like cd type. So this is the directory you can copy and paste. There's a code called, and then the error code is run pi parallel MPI slum. This slum script will call the R script here, the pi parallel MPI R. Actually, it's a Monte Carlo simulation of the Monte Carlo methods of estimating pi numbers 3.1.4. If you don't know the Monte Carlo methods, you can Google it. So that's the way to learn it. You can see the pi examples here. Actually, parallel the process. If you use more parallel process, the pi numbers will be more accurate. So right now using like 16 process, and then combine the. It's actually like when you're using the Monte Carlo methods, you actually throw in those points on a paper square papers, and then counting how many points within a circle, how many points outside of circle. And then do the parallel method is actually putting layers, multiple layers of these papers, and then throwing those points on papers, and then throwing another batch of points on papers, and then you can get like 10 layers, and then sum them up, you will get more accurate estimate of pi. So that's basically the example it's doing. Right now, do you have any questions so far? No? No, I teach the GPU, and I think the guy who wants to know is already gone. Everybody wants to know it. So I teach you without him. Probably not a good idea, but let's do it.
Get the people online.
Okay, you can ask questions now when I go into the automatic uploading. Am I talking too fast? Okay. Everybody can follow that? Everybody can understand?
What?
Okay, I'll teach you once again. So the offloading, can I start? It's automatic offloading is actually the step which will compile over, against the Intel compiler, and there's a library called what's the kernel mass library, KML, right? And then, but some computations actually get faster using the MKL, but mostly I tested the most fastest with calculating the covariance matrix, and then it can be only using maybe 10% of time to finish, rather than you not using the MKL. So if you have interest, you can test the R stats using a R benchmark code called benchmark 2.5. You can Google it. There's about 16 operations like matrix multiplication, and then doing some LU, and then doing some other like simulations, or doing some means matrix multiplications. So you can take a look at the benchmark 2.5. So you can test it on your Mac and test it on our cluster to see your Mac is faster or our cluster is faster. And that's talking about those like MKL and BLAS and some mathematic libraries and LAPACK. So you don't need to know the details about those math library, but underlying they actually load those like BLAS and LAPACK. So it's not very easy to install those like LAPACK and BLAS, especially using R. And CPU already covered, and then Intel Xeon Phi coprocess is actually, because we requested those nodes using mic, so then you cannot launch the RStudio today, because we want you to try the mic. And also the GPU also equipped another Stampy or Maverick, you can try. And then there's a 2Q, one is the normal mic queue, and the other is normal 2 mic queue. The normal 2 mic queue is actually equipped with 2 mic cards, and the mic queue is only 1 mic card. So, but I tested the performance using the benchmark 2.5. I don't know why the 2 mic cards still did not get speed up. It's very weird. I still investigate it. So if you want to use MKL, or if you want to use a GPU, how many of you use the Hyper-B package? No? You're coming back? So that's the section you want to listen.
Yeah.
You're uploading using mic and coprocess. So we just started, so you can catch up. And basic mechanisms is the ARS that built against the Intel, and then the Intel have the mass kernel libraries. You can do matrix multiplications and those operations faster than not using those libraries. And if you want to use GPU support, have you ever used the Hyper-B?
Well, the offloading, that's actually where we got into trouble.
Okay.
Yeah, could try to help out, and then things stopped working.
Okay, I can send you those code scripts, and the Hyper-B actually supporting two parallel mechanisms. One is the multi nodes, multi-cores, and the other is the using the GPU. So you only need to set one variable to true, and then you can use the GPU to speed up your computation. So that's the benchmark 2.5. You can see into detail the mic speed up and the multi-core speed out and the GPU speed out. So there's several, so about 16 operations. So the 17 is actually, I think maybe 17, yeah, 17 operations. And then you can see the speed up by mic is actually faster in the operation 5, and you can look into the benchmark 2.5. There's to see which operation is actually speed out a lot. I guess it's covariance matrix.
What are the axes?
What's that?
What are the axes for this plot?
The x-axis?
Yeah.
There's several mathematical operations like calculate the covariance and do matrix multiplications, and for others maybe randomly generate random distribution numbers and then calculate the mean, or doing the for loop.
So these are labels for different kinds of
different kinds of operations, mathematical operations. So to test the speed out by these three mechanisms.
Is higher better?
Yes. Yeah.
What's for?
I don't know. You can check the benchmark 2.5. It's a secret.
Why doesn't it have a blue bar?
unless you check into the benchmark 2.5. You're too lazy to look into the benchmark 2.5, right?
That's funny.
So could you tell a little bit more about the two different approaches, right? The multi-core and GPU.
Multi-core and what?
Can you tell a little bit more about the two different approaches?
Yeah, actually the multi-core is multi-core. That means you use the like for the system they have like 16 core. You use 16 core on your computer resource, but those memory are shared, right? If you use the mic card, actually moving those computation to the mic card, you can see how many. The mic card should be more CPUs than more advanced computing capabilities in using mic, and also in the GPU. Because when your computer using them, if you play games, you see those like rendering is very fast. So actually using the GPU to doing those rendering and then for the display.
So is it either or? Because I thought you could do multi-core and then also on top of that upload to the.
Yeah, we're trying to do that, like doing the same time using like multi-core and then offload a little bit offload a large proportion to the mic.
Yeah, because that's in the batch you can actually set that, right?
Right. You can say how many percent.
Yeah.
I will talk about it later. You can say how many percent you running or your local host running the host, and how many percent you can run in the mic card. So you can set one variable there. Offloading. I'm talking too much about that. Limitations. Yeah. This is the slide. Only support limited computational operations. That means only speed up a little bit. How? Already talk about how, right? So here's the flag. You can set the MPI mic enable equal to 1, and then number of threads, that means number of process, mic. OPM. I think one of them is setting the multi-core, and one of them is setting the mic process. There's a percentage that you can set. I can send you the submission script later if you really need it.
I'm sorry, we need to recompile R?
Where?
We need to reinstall R packages?
No. You can use the rstat package, the modulo rstat,
Okay.
and then they would already install all those necessary packages, including the Hyper-B package, I think. Yeah. No, for the Hyper-B and Hyper-M package, they actually develop a patch version of R, so we cannot build it under the standard R, because the development team doing some manipulations in the core R package, so they can use the Hyper-B and Hyper-M on top of it. So you have to download the patch version of R from their website to do the GPU speed out and the multi-core speed out.
Which website?
You can Google it, Hyper-B. Then the first one would be the website, the developer websites. You can download it easily.
I'm sorry, I'm not familiar with Hyper-B.
You can Google it, just like high performance linear algebra, something, blah, blah. Hyper-B. So should be high performance linear algebra. Right. I don't know. Because there's a B and there's a M. You can ask the developer.
Oh, matrix and vector. You know, like
B.
AX equal B, and yeah,
The
I
M?
think that's what it is.
I don't know. I don't know the idea. But I have test both, they all perform pretty well. So, but that's one challenge you have to install by yourself. So that's one exercise if you want to challenge yourself. Just install these two packages. That'd be sufficient enough. Where?
So, quick question. GPU is this graphic processing, right?
Yeah.
Talk with this computer scientist is that this kind of processors, they can do some kind of operations really, really fast. So that things very, very slow. The linear ones very fast. Is that right?
You can try.
I don't know.
Yeah, you can try it and then tell me.
It has some vector instructions that are not available in CPU.
Okay.
So you can, those are useful for processing basically like for graphics. There are certain linear algebra operations that they use. So pretty much.
Where is my slide? Here.
The linear algebra operation.
Okay.
The vector addition, matrix multiplication.
Right.
Rotation
Rotation
probably
really fast. I think it's really, really fast because the graphics is probably not rotation. Right?
Yeah.
It's kind of
Yeah. Right.
So if you have an optimization problem, it's probably which is a non-linear problem, is that right? It's not that fast.
It depends. I think each iteration has a linear algebra operation. You could probably offload it to the GPU.
So maybe those online people cannot hear you conversation. So let's continue.
Okay.
And you can talk after like 11:45. There will be like questions and discussion sections, and then you can talk. And the offloading example, the Slurm script is like this. So that means that you can practice. And there's a practice example. It should be within the folder here. So you go back to the work folders. Everybody can see? Yeah, go back to this folder and then ls. Oh, no, I didn't get into it. Okay, that's on cd. There's automatically offloading folders and multi-core and then Snow RMPI. You can test these 3 folders by yourself or after the class. I think that's when you dispatch the submission script, you showing up those informations in the home directory. Or stuff. You have ever used the submission script, so you should be familiar with this slide. And the other command you use on Stampy is SQ, that means, and then -u, and then your user's name that will show you the running jobs and then the running status. And then if you want to cancel your job because you think the script is something wrong, and then you can use scancel command, and then just scancel and then put the job ID. Probably, yeah, the job ID should work. So there's another way to doing. So somebody asked, you can run in your R interactively using the RStudio or using the terminal, and also you can use the batch mode. That means after you debug, there's no bug in the code, and you can use the batch command, but you have to go into the compute node. Remember, do not do the computation on logging node. So that's one thing you should remember forever. And then that's the arguments you can pass in, how to pass in the arguments. That's one way. I think David provided a much complicated way to cat the script, the .r script, and then pi, and then run the R, and then slave, and then arguments. And then this is the first argument, this second arguments. But why there's 4 and 5? Do you know why? There's getting the argument from the terminal. Why there's argument getting like 4 and 5? I think there's a 1, R, 2, 3, 5. 1, 2. Yeah. The other way to do it, not using this, you can teach you one way. You can write something like this, maybe. Some examples. Lot of article. Let me try here. So if you want to get arguments from terminal, you just like command arguments and then trailing only equal to true. That means you only count the arguments after the R script's name. So if you want to put in the first argument, just type arguments double bracket and then 1. That's the first argument when you run the R script. That means here it's like run R script. Do I have R? Login, no R, modulo. Just run R script and then put something like example R. And then whenever you put a first argument, it's this one, and then second argument is 2. This will be the first argument you get from the arguments 1. Let me see if you have something like iterations. You go to the first argument. That means you can submit the job using R script, and then exercise 1, 2. So I think it's equivalent to this one. To this one. So you get the same result if you put the those commands arguments here, and then there'll be like the arguments, like double bracket one, and you can get the arguments. There'll be an easy way, but if you want to do the hard way, it's up to you. Running R with parallel package, I already talked about that. Multi-core, no RMPI. So you can do those exercise in that folder. I think I already finished. Yeah, questions.
So can you go back to the RMPI? So do I understand correctly? RMPI is the most basic one. The slide with RMPI.
Yes, RMPI is actually the most basic one. Is actually give you some functions can use. The equivalent function you can use using the MPI. So you like a send, receive, and collect those commands. That's the equivalent one in R. So it's very.
And the snow is like higher level?
Yeah, it's a higher level. It's like basically probably using the RMPI underneath it. So yeah, so you don't need to like you don't need to write something like send and then to know, okay, what's the rank, common rank? So 1, 0, 1, 2, 3. So you don't need to do that. You just like only care about your programming, only care about your scripts, like only writing the for loop and then do part. So that's the one you need to do. And underneath it, probably you call the RMPI and then sending those jobs to like ran 1, ran 0, and then collect them together. So that's the.
We use cluster apply.
Okay. Right. So it's a good question. Yeah. So basically, R has many package and doing the same thing. So nobody know which package perform the best. So sometimes you have to doing some testing, performance comparisons. So you have to figure out like which package actually you need. So right now, the R, when you go into the R developer website right now, about 7,000 package available for you to use is in the CRAM repository. So every time when I check it, last time I checked it, it's over 6,000. So it looks like maybe every year increase 1,000 package. So
7,200 now.
Yes, I checked the number. So you never know which package works, which package has bug. So be careful. So that's why you need to compare, do some experiment. Any questions? Because I almost cover all the materials here. The other thing I want to mention is the data table package. In R, the default read dot table, that function is not very efficient. I have compared the read dot table with those Python read table equivalent functions. And then the read dot table function, you need to, if you want to get it faster, you have to define an argument called column class. That means the first column is if a numeric, you have to specify the columns data type. That means you will gain the whole data frame faster than you're not specifying those column classes. And that's one thing I want to mention. And if the read dot table function still too slow, so then you can use the data table function. So it's actually a faster way to load the text file and then separate it by anyone like comma or space. I also test the data table package. The read dot table function is actually called fread, probably stand to fast read. And then you can see I tested loading. It's no any problem loading a 33 gigabyte file. So very quickly, it will show you the how many percent you already loaded into the data frame or the data table objects. And if you still think the R package is not efficient, then you can challenge yourself. Then programming your own R package using the RCPP. There's actually an interface using C++, and there's some similarity between C++ and the RCPP's grammar, and you can do it program by yourself using the C++.
There is also another package that's called inline.
Yes.
You can actually just, inline, you can put C code in the same
Right,
line.
right.
It's very convenient.
But be careful. The RCPP package, it's not very easy to debug your code. So if you have any problems, don't send me ticket because I don't know RCPP, how to get RCPP run, and I don't know how to debug RCPP program. And there's another one, big memory package, and it's very straightforward. When you have memory problems, you have to look into the big memory package. And the other one is a PBDR. This one is a good one. And then you can do the RMPI, send and receive command using this PBDR package. And I have tested the performance of PBDR using the MPI standard. The PBDR is much faster than the RMPI package. So you can try? Yes.
Good to know.
Yeah. So I told you many things, good to know. And also the PBDR also supporting distributed matrix multiplication. So you have a large matrix. You can use the one package that can distribute your matrix to multi nodes. And I think that's another good thing you need to know. For others, if you want to learn by yourself, then you can go to the CRAN website. There's a high performance computing task view. Then there's all kinds of high performance package there. And it's very fun to know those packages, but I'm not sure those will eventually work or performance will be better than other language, and you can test it. Yeah, that's the email you can send if you have questions. That's not mine. Then you just send to David Warren. Then he will answer your questions. But just kidding, just kidding. You can send those tickets. We are very welcome those tickets because we want to know new problems in high performance computing. We're also doing some performance comparisons among those package. So just send us tickets and then we will resolve those issues. Yeah, all tickets are welcome. So you can send into the data intensive queue. So there's a queue in the ticket systems. You have any problem, just send to the data intensive queue. Then we can reply to you if we know. But everybody's knowledge are limited, so maybe I can resolve the issue like within 1 hour, maybe never. Well, who knows? You can try this, and then probably you can Google it. If you can Google, get the answer, just don't send ticket to me. Well, yeah, pretty good timing. I finished in 11:45. So, any complaint, you just can send a ticket, but not to me. Well, maybe to my supervisor. Well, the last 15 minutes, you can do like exercise in the directory using the mic offloading or GPU. And if you want to try the Hyper-V, you also can install by yourself. If you have any problem, just send me an email. And then my email, I'll let you know my email. Otherwise, same ticket. So, my email is rhuang. Can see. Another one. You can search my name on tech directory, then there'll be.
Oh, you're not.
He's probably put up a fake name.
No, that's
No.
that's him, but what's mine? It's not like
I can put it here, right? So, here. That's my email. Tag. Okay. That's it.
There's a job script called job.mic under our HPC folder.
Yes.
There's a compliance specified at KL host work division 0.3 and mic division 0.7. How do you get those numbers?
Stable.
How do you split
Oh, that's
that?
30%, and 70%.
Right. So then how do you decide those numbers? How do you, where
We
those
got
numbers come from?
testing the performance. We use like 70% of the mic and 30% on the host. You get the best performance for one mic. Very good try. Switching number. Just use the normal mic queue and the two mic. I don't know why. Any questions?
any questions online?
Okay. I just posted the notes.
Oh, there's about a minute delay, minute and a half delay between the video stream. So we should know. I'm going to go ahead and stop the audio broadcast and disconnect the webcast right now. But I want to thank Riju and Amit for presenting today. If you have any questions, go ahead and email Riju, or you can contact me. My name is Jason Allison. My email is jasona@tac.utexas.edu. And I'll be happy to help you out. Thank you.